right.
Okay, let's see what happened. Hey, Coleman!
Hello.
Good morning. Hi, Mr. York.
Morning.
Good
How
to
are
see
you, Blake?
I'm okay.
Yeah.
We're snowing here.
We were just talking about the snow. Are y'all already getting stuff?
We are, but we're not supposed to get 3 feet of snow like New York is.
I
But we're
do
getting
not
some.
miss the weather. I don't miss the Baltimore, Washington weather a bit.
Well, you know what? I have look, see? There it is. Excellent.
So we're going to knock on.
Okay, thank you.
Absolutely.
Bill,
Do you need a hand moving any of this before?
You know what? I'll make my students do it.
Okay.
In any case, so it's just really started. It started snowing here about 8 this morning, but it's just a little too warm for it to stick.
Uh-huh.
So hard for me to say. We may.
Are y'all supposed to get much?
You know, the predictions are all over the place, so I couldn't really say.
Yeah.
Maybe, maybe not.
Huh. Interesting. Well, good luck with
Yeah.
it. Stay warm. Maybe you get a day off.
Maybe so. Do you all ever have snow days? I bet you do.
We get a nice day. Maybe last year, Coleman? We closed one day last year, I think.
Yeah, and we had a 4-day period 2 years ago.
Yeah.
Which
It
is
just
awesome.
gets cold and yucky here. Cold and
Oh, that's
windy.
right. I remember. It was around Thanksgiving.
Yeah. Well, February normally is when we'll hit something.
Yeah, but last year there were some big ice storms around Thanksgiving.
We only got another month to get out of it.
Yeah.
Then it'll start to get
Okay, I
warm.
just thoroughly screwed up the.
The one was right before winter break 2 years ago.
Yeah, I remember that because we had snow at Christmas.
Yeah.
I have pictures of that even.
So someone has exams today. Can you imagine?
All right, you feisty crocs, I'm in here today. No, not really. But we can pretend.
Wow, Jack, that's a terrible British accent. Hi, Max.
was the year.
Hello, how are you?
Were just
I'm good. You're wearing.
That works
Coleman
in
is
the
wearing
middle.
shorts. I'd like to point out.
I'm not.
That works in the middle. I'll put that in.
Okay.
way convenient.
Oh.
Try it. Well, it's not allowed.
Jasper. I see Jasper's. Hi, Isabel.
Hello.
Hello. Yes, please do. I just was trying to move closer to the camera because to the screens actually. Hi everybody. It's 12, so we should get. Yes, he has already sent me a note about that.
Sorry to keep you waiting.
Notice Coleman's wearing shorts, guys.
Oh my god.
I know. Imagine.
Oh yeah, nice.
That's solid paradoxes.
It's actually.
Okay, you all should move here. Someone should sit here, and you should sit there. There you go.
It's a brisk 65 here.
Brisk 65. Wow.
Yes.
That you must be freezing, Coleman.
Yeah.
Almost to pant weather. I feel like mind the class, so I don't have my calculator on me right now.
Okay, you don't need
I
a
have an
calculator. You don't need one, I don't think.
Well, I like
Hey,
Like,
Isabel. Isabel,
Yes.
did you explain to all of your classmates that we heard when they got back on Thursday?
Yeah.
And they were unrepentant?
You're also unfit.
Yeah, I mean, I don't want to speak for their emotions, so we should put them on the spot instead.
And did you also explain what an awesome class we had on Thursday?
We actually did have a really great class without them there.
So, I don't know. Draw your own conclusions, guys. I don't know. I mean, what can I say? Okay, here's my high school schedule. I hope you all agree that this is what your high school schedule looks like. I'm ready to get started, and it's 12:02, so I think I need to put up the first problem. So here's my first problem for today, and we will get everyone settled, and hopefully we can do this problem.
Very fast.
Stop.
Yeah, the slide looks a little weird, but it's x plus y equals 2 is the constraint.
Nothing's being shared.
Yeah, actually, let's find where I actually took some notes.
Oh, you know why? Because
Are you in the Thursday one?
yes. Sorry, guys.
It's okay.
It's Monday.
It is.
So sorry. No wonder no one's signed in. Okay, there's someone. Who is that? That's Trinity Prep, I think. Okay, so sorry. Let me.
Kevin's a student today.
So sorry. Let me find the document. It will just take a second. Hi, Trinity Prep. Welcome. It's snowy here.
It is.
Why do I only have pens?
Do you want a pencil?
Yes, please.
I'm so
Thanks, Tom.
nice.
Okay.
Oh, no, it says $2 pencil.
Sorry for that goof. I put everything on Thursday instead of Monday, and it's Monday definitely.
Should we
Okay.
just log into Thursday then?
I did. No, it's okay. I repaired it. It's just going to take a second to come up. Okay, so on Thursday we talked about Lagrange multipliers, and most everyone used Lagrange multipliers. I think everyone did in their dumpster problem. I have a quibble with the dumpster problems. I have never in my life encountered a dumpster that looks like what most everyone wrote about, which is a dumpster that is a rectangular solid. I've actually never seen one, and I'm not being disingenuous. I'm not making that up. Most dumpsters, almost all dumpsters, have a trapezoid as one of the faces of the dumpster, just because of practically how they work. You know, they're putting the things on the side, they're putting like some kind of, I don't know what you call them, and they're bringing it up. And for the stuff not to fall off the back is typically higher than the front. Now, I didn't make a big deal about this in grading, but that's something I really noticed. Are the dumpsters that you looked at truly rectangular solids? My guess is no, but I could be wrong. But I just invite you to look at a dumpster more closely. Okay, here was the problem I wanted to start with today. So now we're definitely all ready to go. And there's Jasper. I see him.
Bye.
So who has an idea about this? I'm curious, just really curious. Okay, Akshay, what are you thinking as you're thinking about this problem? Besides how much you like me.
Oh yeah, I was thinking of like working it out, so I started with doing the partials of the function.
Okay, so what'd you get?
F, the partial with respect to x is y, and the partial with respect to y is x.
And what did you what like physically what numbers did you get, or symbols? So what did you get for the partials? What did you get for the gradient of f?
Oh, y comma x.
I got that too. Excellent. What did you get for the gradient of g?
Well, 1, 1, 1.
Yeah, I got that too. Good. So we're on the same page. Good. Okay, Isabel, what next?
So once you have both gradients, you set them equal to each other, but multiplied by lambda, so you get y equals lambda and x equals lambda.
True. That's what I got. Okay, and so then what?
And Isabel still?
Yeah.
Sorry. Okay, and then, so this to me looked a little funny, so I was like, I need to use another equation. So you also have the equation x plus y equals 2.
Uh-huh.
And then also, I was wondering, because you have the maximum value already, if you should incorporate x, y equals 2.
Okay, that's a great question. So you have y equals lambda, x equals lambda. Is that right, Isabel?
Yeah.
Okay, I agree with you. Samya, what do you think should happen next?
I think it would just be y equals x.
I like that. Okay, and then what do you do?
Didn't even make any sense.
So I guess, it would just be 1, 1. Because if you use
Okay.
the x plus y equals 2, then you have 2x.
Yeah, you
equals
use
2.
that equation like Isabel suggested. You use y, that the other constraint
that doesn't-
equation.
But that doesn't make sense because x times y needs to equal 2 to meet
Well,
the
it says
maximum.
what is wrong with this statement, Isabel?
Oh, there we go. Sorry.
So what is wrong with this statement, Isabel?
That the maximum does not equal 2.
Yeah, what is the maximum equal to?
1.
I think it's 1. Okay, so that's a really simple problem to get us started and to make sure everyone knows what to do. Okay, everyone clear with that? Sound good? Sound good? Hope that sounds good. Yes, no? Max, you okay? Yeah, okay. Okay, so let's do a little harder problem. Okay, this is quite a bit more challenging problem. So it says find the maximum and minimum values of that function subject to the constraint. What is the constraint, Logan? What is the image that I'm thinking about? What is this thing represent?
That's going to be a circle with a radius of square root of 10, I think.
Excellent. Okay, that's a circle. So it's like we're thinking about stuff inside the circle. Okay? What was your question?
I was gonna say like filled in.
Yeah, it's a filled in, like the what did we say? The boundary is part of the issue. Yeah. Okay. So again, see if you can conquer this one. I have faith in you. This one has some interesting qualities to it. Okay, I want everyone to pause because I just have no idea how to start this problem. Coleman, can you give me some advice on how to begin?
You want to take the partial with respect to x and y.
Okay, cool. So I want to find the gradient of f and what else, Coleman?
And the gradient of the constraint.
Yeah, okay. So just to make clear that that's where your first step is. Thank you, Coleman. Eric, I see you looking puzzled. Tell me where you're stumped.
So I found the gradients and I set them equal to each other.
Okay, can you tell me what gradients you got?
Sure, so for the gradient of f, I got 2xy, comma, x squared plus 6y minus 1.
Great.
And for the gradient of g, I got 2x, comma, 2y.
Okay, so what was your system of equation?
2xy equals lambda times 2x, and x squared plus 6y minus 1 equals lambda times 2y.
Okay, so you should be working with those equations. Now, do you know any solutions to those equations?
So, if x, oh wait, never mind.
Okay, that's fine. Samuel Levitt, can you help him out? Do you know any solutions to those equations?
Do I know any solutions?
I know a solution to the first equation.
I'm a little confused by what you mean solution.
What?
I'm sort of confused, but what do you mean by solution? Like for
well, I can find a value of x and y that solve, actually only x. I can find a value of x that solves the first equation.
Oh yeah, I'm pretty sure that would work. Yeah.
So what do you think?
If x is 0 and y is 0, I guess.
Y of x equals 0 is. Do everyone agree x equals 0 is a solution to the first equation? Okay, yeah. But then what can I do with that, Sam?
I don't know what you mean by that.
Yeah, me neither.
Well, isn't x equals 0? Doesn't that make the first equation true?
You mean with 2x lambda equals 2yx? Or with...
I think the first equation is 2xy equals lambda 2x.
Yeah.
That's the same thing. Okay. But wouldn't you just say that therefore lambda must equal y?
But if x is 0, then you can.
Interesting.
But that's what I said.
Well, I'm trying to find some points, right, that make this true. So, doesn't x equal 0 work, Isabel?
Yes, I guess.
Well, that just gives me some y values that also work. That's what if x equals 0, I can get some y values that work. What would the y values be? Is Charles there?
Yeah,
oh, Charles, I can't see you. So you need to do some fiddling with your camera or move. There you go. Charles, Max, I know. Can you move closer to Isabel so that I can see Charles?
Yeah.
Okay, thank you.
Remember when Charles said he didn't want to?
I know. I remember too. It was awkward. Okay, so let's see. Raheem, can you help me out? If I say x equals 0, I can find some y values that work. What y values?
You could get y would have to be less than or equal to root 10.
Okay, I got y equals plus or minus root 10. Okay. Now, what can I do with that y value?
Sorry.
Any idea? Yeah? No one believes me? Do you think I'm making this up? Isabel's not convinced that this is reasonable.
I'm sorry, I was just trying to fix this and was not being successful.
But do you understand what do you not believe me that x equals 0 is the solution to the first equation?
I get that no, I do believe that if you plug in x equals 0, then both sides equal 0. I just, I feel like in all of these problems, we're always looking to solve for x in terms of lambda or solve for y. And so when you get something so simple as lambda equals y, I don't understand why that wouldn't be
it may
what
work.
you
You know what? You may be right, Isabel. It may be a good way to approach the problem. I just was trying to find, you ever hear the phrase low-hanging fruit? It's like the easy stuff you can reach up and get. That's that's an easy solution that I just happened to notice. So maybe you have a different notion, Isabel. Do you have a different way of doing it?
Well, but then I have a question. If you know that it works for the first equation, but if you just plug in 0 for x in the second equation, it doesn't
help you.
True that you know that it works. So don't all points need to satisfy both equations?
Well, I think it could satisfy the second equation, but I don't know what lambda. I have too many unknowns in the second equation, Isabel. I have two equations. I have two unknowns in one equation, so I can't say for sure. There is some lambda that works with x equals 0 and y equals root 10 and positive root 10, negative root 10 and positive root 10, but I don't know what it is. I mean, I could solve it, but, doesn't help.
In that one circumstance where it's like if we assume that x equals 0 and then we try to find our y for the other value, we can't use y equals lambda because we assumed x equals 0, which doesn't work to do that.
Right. So I actually did. Sorry, I think I just lied to you, Isabel. I did solve for lambda myself, ultimately, using the second equation and using the idea that x equals 0 and y equals positive root 10. Does that work for you or no?
I mean, but y equals positive root 10 only in one instance, only when x equals 0.
Right. So I need to find some ordered pairs, don't I?
Right.
Okay. And then how am I going to tell which?
So you're just using that to solve for lambda, you mean?
Okay. Yeah, or for x and y. I really want x and y, don't I? Because I want to find what f of x and y is at several different things. Alex, did you get any numbers?
So I said that lambda was equal to y, although obviously x equals 0 is a different scenario. And then for the second equation, I said x squared plus 6y minus 1 is equal to lambda 2y. So then therefore lambda is equal to x squared plus 6y minus 1 all over 2y. And then I set that equal to y. And then I just put all the y expressions on one side and all the x expressions on the other side, because you don't actually need to solve for x if you want to plug it back into the original equation. You can just solve for x squared, which makes that easier. So I got that x squared equals 2y squared minus 6y plus 1. And then I substituted that for x squared into the original f of xy equation. And that actually simplifies nicely down to basically, in terms of y, f is just 2y cubed minus 3y squared. And so I took the derivative of that, set it equal to 0, and then I found some y values for that.
Okay, that's interesting. So you actually made it a single variable calculus problem.
I like that.
Interesting. Yeah.
Well, I don't think he does.
Yeah, I'm outraged. That's all I can say. Not outraged.
Wait, Alex, how did you do that?
So she basically solved for. Go ahead. Explain the general method without.
So when I set the lambdas equal to each other, I just cross multiplied and I got 2y squared minus 6y equals x squared minus 1. I also did some combining of terms and algebra and whatever. And then from there, I got that x squared can be equal to 2y squared minus 6y plus 1. And so to find the minimum and maximum values of the original f of xy expression, I just plugged in 2y squared minus 6y plus 1 for x squared into that to make it the entire expression in terms of y. And then I took the derivative and found values, set it equal to 0, and then found values for y that satisfied it.
And what were your answers, by the way?
I got y equals 1 and y equals 0, but I don't think that an x value can exist for y equals 1. So
I think I have some pretty different kinds of answers. So that's one of the things. So you converted it into a single variable problem, but we're looking for z values, right? Mm-hmm. Not y values. So maybe you have to put back your y values in that expression and see what you get. But so you found some y values, haven't you?
Yes.
So you might actually have the right numbers. I don't know, but I want to try to do some multivariable stuff here. Okay, so Jasper can't talk. He tells us, "Sorry, Jasper. Sorry." Julius, you want to help me out, or do you want to ask a question?
Another question, yeah. So we've been talking a lot about plus or minus square root of 10, but that's also it's less than maximum. Never mind.
Yeah. So it could be on the boundary.
Yeah.
Right? Okay. I need some clarity. Let's see. Samia, what are you thinking right now?
I was thinking that, originally when we got, the x value, I thought that, plugging in, after that we could plug in, the y value that we got for the x value into the second equation. Because with y equals lambda, because since that's also a solution to the first equation.
Yeah.
But I don't know if we're allowed to do that because technically x equals 0 and y equals lambda are two different solutions.
Okay, so I think that you are right. They are two different solutions, so hold that thought. Logan, you have a question or an idea?
I have an idea. We'll see if it's
I love
useful.
it. Let's hear it.
So we have, so I started with the y equals lambda approach, and then the next, I guess, equality that we have is x squared plus 6y minus 1 equals 2y lambda. So using the knowledge that y equals lambda, I set up a system of equations, I guess, substituting in y, or lambda for y for lambda, whatever the terminology is. So I got x squared minus 2 lambda squared plus 6 lambda minus 1 equals 0, and then on the bottom, I have x squared plus lambda squared is less than or equal to 10, and then subtracting the bottom from the top, I got negative 3 lambda squared plus 6 lambda minus 1 is greater than or equal to negative 10, and I think I did the flipping the inequality sign correctly. Correct me if I'm wrong.
Notice I'm applauding you. Okay, so that's good stuff. So, Logan, you got an expression in y or in lambda?
In lambda, which is, I guess, could be the same as y.
And what was your expression in lambda?
Negative 3 lambda squared plus 6 lambda minus 1 is greater than or equal to negative 10.
So I have almost the exact same expression. I think you made an algebraic error somewhere. So I have 3 lambda squared minus 6 lambda minus 9. Oh, actually, that may reduce to what you had. Right, because you had minus.
That makes sense, actually.
Yeah. Okay. And how do you solve? That's in a quadratic, and how do you solve a quadratic? You set it equal to.
That was
0.
0, sure.
Right, and then you solve for lambda. You get 2 lambdas. So I did that, and I got lambda equals 3 and lambda equals negative 1. Now what do I do?
Can we write this?
Yeah.
What would you like me to write?
Whatever your question is.
From the moment when he said.
So I think what Logan did is he let y equal lambda, right?
Yes.
Okay. You put that into which equation, Logan?
I put that into both the x squared plus 6y minus 1 equals 2y lambda, and also the x squared plus y squared equals is less than or equal to 10. So both of those equations.
So the first 2 equations, okay? So the first 2 equations we started with, and you do some manipulation.
I haven't finished yet.
Okay? And you get this equation. Let me write an equation here. I got this equation, x squared plus 6 lambda minus 1 equals 2 lambda squared. Okay? I got that equation. Now, I think we went about it slightly different ways. Logan did something different, but I knew what x squared was in terms of y, right, because of the constraint equation. I knew that x squared was equal to 10 minus y squared, which is the same as 10 minus lambda squared, right? Right, Logan?
I was...
Yes.
Say it again,
so
please.
10 minus y squared is equal to 10 minus lambda squared, right?
Yeah, that would be correct.
Yeah, okay. So I just plugged that in, and I eventually got this expression. And I mean, this is all just algebra I'm doing.
You take the derivative of that?
No.
Just leave it there. Okay.
I mean, I'm trying to find the lambdas that make that. So I'm trying to find the solutions to that equation. And I got lambda equals 3 and lambda equals negative 1. So I think that's something Alex is bringing up, which is a good thing to bring up. You know, the only derivatives we take are when we're taking the gradient. Right? The rest of this is just algebraic manipulation. It may be hard algebra, which is why I chose this particular problem to do, because it's got some tough algebra. Okay, so I think that will lead us to some solutions. Charles, did you ever get a max or a min?
Yes, I found as a max. I haven't checked the bound, which is 0, 0, but I think that's just going to be 0. So the max that I found is root 10 plus 30, which is about 33.162.
Yeah, so I got this. Wait a second, Charles. How did you get that number?
So the lambda solutions that you get from those equations give you 4 possibilities for points.
Yeah.
That are maximums or mins.
Right.
And one of those points, 0, negative root 10, gives you about 33.162.
Yeah. So that's one of the. So you actually are going to put, after you find the lambda, you're going to put them back into your x and y. You have a whole bunch of solutions. I can't remember. I have
-3.
I have a bunch.
-1.
I have 6, I think.
4.
Mr. Spraggins.
Yeah.
I'm just very confused. Like I feel like I understand the individual methods, but I feel like everything is just really contradicting everything else. Like now we're using y = lambda for this one, but then we're saying that it doesn't always have to be true, like because we solve for different lambda like using the first method we talked about where x = 0, we got a lambda value. How can lambda be a different value every time? And how, like, I don't see the bigger picture.
So, Isabel, I could have solved for lambda in my first expression, and I hope I would have. I haven't tried it. Okay, let me ask you a different question. This is something. Go ahead.
Sorry, I was just gonna say that I solved for it using when y is less than or equal to √10.
And what did you get?
I got -1 divided by 2√10 all plus 3. So I'm sure that's
okay. So that is I got simpler lambda expressions. But so you ask a really interesting question. Does the lambda always have to be the same for these things?
Apparently not.
Well, I don't know. I'm asking you a question. I mean, I know, but I'm asking you what you think.
Well, I would say yes, because this whole thing comes from the normal line and the gradient. And we're saying that we know that they go off in the same direction. We just don't know what is the coefficient or the length, the magnitude of each vector. And then we come up with an answer in terms of lambda. And then to say, well, I guess it makes sense though, because the function touches at all different points. So maybe.
Right. I mean, and you can definitely get more than one value of lambda for the. I mean, in any method I use, I'm going to get multiple levels of multiple. I can get multiple answers for lambda. So your lambda may be right, Isabel. I mean, I don't know. I just chose not to solve it that way because I didn't need it. Because what I'm really looking for are x's and y's, right? Do you agree with that, everybody? Nod your heads complacently. Yeah.
So,
I mean, you really only care about x's and y's. The lambdas are are something. They're a tool you're using to get to the x's and y's, which may be something you don't love. But I mean, I only want x's and y's because what we have to do ultimately is I need to check f of xy at all my possible values of f of xy, and the biggest one will be the max, the smallest one will be the minimum, et cetera, et cetera, et cetera. Okay? Yeah, Eric.
So is there a reason why you decided to solve for lambda? Because I wasn't here in class on Thursday, but in the video, I think you said you sort of solved expressions for lambda and then set those equal to each other, so lambda would just cancel. You didn't actually need to find the value for it.
So in the second way, I did it because it was algebraically easier.
Okay, so
I mean,
it's
like
works,
I was just trying some different algebra.
I was confused about before.
Yeah, I hear you. I was just actually trying to do the problem, and I couldn't do it with finding x. I couldn't solve it. I would have gotten much uglier expressions solving for x and y.
Okay.
So it's a great question. I mean, truly, I'm just trying to find x's and y's. If you can find them without solving for lambda, that's cool. Okay. But I think that this one is harder to do. Isabel.
So then my question is, when we use Logan's setup where y = lambda, plug it in, find solutions, are we doing y = 3 and -1, or are we doing lambda = 3 and -1?
I eventually solved y = 3, and then I found x values that went with that y = 3.
Okay.
Because my goal is to find ordered pairs of x and y.
And so is x = 0 a solution?
X = 0. So one solution pair is 0 √10, and one is 0 -√10. Is one solution pair that makes this true.
Okay.
And then because those are actually on the boundary, right? Yes, Alex.
So I'm just a little confused by this idea of the constraint. I get that it's a filled in circle. Are we just assuming that all these extrema, the maximum and minimum values, are going to be at the edge of that circle?
Doesn't have to be. I mean, on Thursday, and I don't have an image of this thing, but I don't know what this looks like.
Right.
I mean, and so it's like this is on the plane and it's reflecting up on this surface, and it's a line on that surface, and it may, be going around like this, or I can show you that if you want to see it, but like that's in the plane, and it's like you're looking at how it reflects on the surface.
Right, but I just feel like we've assumed a few times that x squared plus y squared equals 10, and so why can't we just assume
Right, well, because I think that, it just has to be somewhere within that boundary. I can't, that's how I'm solving the constraint equation. I'm looking at the boundary and not the interior. I think the minimum is actually on the interior. It's not on the boundary. It's some number x and y within there.
Okay.
Okay, go ahead.
Using the method that Alex started going through, you get the same answer. So is that?
Yeah, I think so. You should get the same answer.
Yeah, so is that like a valid way of doing
Absolutely.
It? Plus or minus?
The thing is that what I don't know about this is that she has to eventually go back. She was still talking in terms of y. So you need to find a z value.
Again, the f value for f of x, y, that original?
Yeah, I think, that would,
Okay.
I don't know.
But you can get the plus or minus, then you get your 4 points.
Yeah. Charles, did you get a minimum?
I got -5 as the minimum.
That is the minimum value. And how did you get that? So
it occurs at the point 3, -1.
Okay, it goes with the point 3, -1.
And, wait, no.
I think so.
Or maybe, yes.
Yeah, I think it's 3,
But it's also
-1.
-3, -1.
Right. So -3, -1 also gives you -5, I believe.
Yeah.
So after you somehow find the x and y, you go back to the equation. The largest is the maximum value. The smallest is the minimum value. Okay, Isabel.
One question I have is the constraint always like a something on the xy plane projected up or down onto a surface?
I think 99.9% of the time, because we almost always have surfaces that are z surfaces, right? That are functions of x and y. If I had a function that was x of z, I would look at something on the xz plane. But this is how we generally look at functions. So yeah, almost always it's something in the xy plane.
So my question, but so then for x squared plus y squared like less than equal to 10, wouldn't that mean it's like a cylinder with height 10 that goes from like z value 10 to 0?
Yeah, again, and maybe I should find that. Again, think about what this is. This is a disk on the xy plane, and you have some surface, which I don't know what it looks like, up in the z plane, and you're looking at the area of that z plane on the disk. I think I have to find that picture to show you all. So sorry about this, but let me find this. I don't know where it is. Oh, it was on Thursday, wasn't it? So, whoa, come back. Okay, let me find the picture that I showed on Thursday. Here's the picture. Can you all see this picture? You look on your screens if you can see. Okay, that's the picture. This is practically this. It's the same sort of scenario, right? Except here, this is the circle in an xy plane, and it's being projected on an ellipsoid. The surface we're thinking about now is not an ellipsoid. Okay, it's I don't know what it is. It might be an ellipsoid, but the red line here is, and actually, I think I need to do this for Jasper. I need to share my screen so you can see it. So wait, just 1 second, Jasper. Hold on.
Or would this be a filled-in circle projected up instead of just a line?
It's just saying that. Well, let me show you in a second. After I can share my screen. Share my screen. Why is it not letting me share my screen? Oh, rats. I don't know why it's not letting me do this. The thing is, Isabel, in this example, okay, are you looking at your screen? I'm sorry, Jasper, you can't see this. I hope everyone else can. In this example, if I included the interior of the circle, my minimum would be 0. I think that thing is on the axis. Do you agree?
Yes.
Yeah, and since I'm only looking at the boundary here, my minimum is like in this region somewhere. Do you see where my thing is going? It's moving around. It's like over here somewhere.
Right.
Since I don't include the interior. Charles?
So, just kind of a side question. If you envision the same kind of paraboloid shifted a little bit, so its minimum was like at 1, 1, how would you find that minimum when you have an inequality constraint like this?
Well, the magic thing about this is I think it always works. The algebra always works out.
But it's not, if you set, when you're solving it with the constraint function, you use an equals sign, don't you? You assume it's at the extreme of.
Well, but I could. But if I included this interior, I would find some things. I would find, like the points that we found too. I mean, that's an interesting question, is like, have we actually found the minimum point, because of the fact that we didn't look at points in the interior, really. So that's a great question. I encourage you to ponder that, Charles, because I think you can figure it out. Okay? I'm sorry, I need to move on because I want to do something else today. I'm glad we talked about this problem. This is an algebraically challenging problem, but I need to move forward. Okay, you have a question quickly you can ask, Alex, or?
Yeah, so then wouldn't you just like want to see, because it's an inequality, like can't you just, and because both x and y are squared, can't you just assume that like the minimum is going to be 0, 0, and then plug that in, and then you get 0?
Yeah, but you actually get a smaller number on the edge.
So yeah.
You see what I'm saying?
But in that graph, so that graph isn't of this focus.
That's right. It's not.
Okay,
that's some random function. That was one we did on Thursday. So I don't know what this graph looks like. I think it's actually. I think it looks. Yeah, I don't know what it looks like. So, okay. I have to move forward, my friends. Let's do a really quick question. So there are these points. Okay, that curly thing there is the constraint. Okay? Do you see the curly thing?
Yeah.
And it has these 4 points, P, Q, R, and S. And it's saying, which of these is a maximum, a minimum, or neither? And can you say why? Okay? Do you understand the setup here? Okay, Julius, want to try? You want to try one of the points and see if you can say whether it's a maximum, a minimum, or neither?
Emphasis on try.
Okay, that's cool. I like trying.
I think S is a maximum.
Okay, I agree. S is a maximum. Why do you think that, though?
Because the F value is the highest and it's within the parameters of our...
Okay, the F value is the highest. It's within the parameter. There's one important statement missing. Logan, can you help him out? What's also true about where the line that S is on?
Well, one thing, is it important that it's tangent to, like, I don't know.
Yes, really know. It is tangent. It has to be tangent for it to be a possible, okay? So if it weren't tangent, I wouldn't know, okay? Make sense? Okay, know. I wouldn't know. It would be
because the what's it called values.
Yeah, that's the whole thing about the contour lines and all that jazz. Max, we have an idea.
Yeah, stemming from what you just said, I think point R cannot be either. It's neither a maximum nor a minimum. Because
that is true.
One, it's not.
Go ahead. You got cut off in the middle.
It's tangent. It's not tangent to the function, and so it's between. You can tell that it's between 30 and 40 or 30 and 50.
Okay, great. So R is neither. Okay, that makes sense because it's not tangent to the contour or the constraint rather. Let's see. Rakshay.
Which one?
What?
It has to be tangent to the constraint.
We beg your pardon.
So can you tell me about? Well, there are 2 other points we haven't talked about. We haven't talked about P or Q.
Which one?
Wait, who?
You said Rakshay.
I'm sorry. I think I said Akshay, really. But Rakshay is kind of a cool name. That should be your your celebrity name, Rakshay. Akshay. So.
So, am I talking about P?
Yeah, great.
If P is a minimum.
And it's an absolute minimum. And how do you know that?
Because it is in the parameter, it's a tangent to the constraint and, it's the lowest value.
Okay, cool. And it's the lowest F value. And Alex, why don't you tell us about Q?
Like R, it's neither. because not obviously there's higher and lower values within and on the constraint, and because the contour line on which Q rests intersects the constraint in two different places in addition to Q.
Well, but at Q it's tangent. Do you agree?
Yes.
Okay, does that change your mind?
No.
Okay.
Still neither.
Okay.
I have another question?
Yeah, but I don't know that I agree with you. So, I mean, at Q it's tangent.
Yes.
So there might be something happening at Q.
Wait, what's the thing?
Okay.
But is it a minimum or a maximum still?
I don't know. I mean, I would say P. Akshay, what would you say about P? How would you describe P overall?
Absolute minimum.
It's an absolute minimum. And S, I think that, I don't know, Julius, did you do S? Who did S? I can't remember. And what is true about S?
It's the absolute maximum.
It's an absolute maximum. Couldn't Q be something?
A local.
Could it be a local max or a local minimum? Could it be?
Maybe.
I don't know. I'm asking. What do you think?
I don't know. I think it just depends on how you define your locality. Probably, but I don't.
Okay.
I'm not entirely sure how to answer.
Sam has an idea. Sam, what do you think?
I think Q has to be a local minimum because on both sides it's heading towards F equals 40. So it's increasing in both directions.
So explain how it's increasing in both directions.
Well, it's at 30, and whether it's going, I guess, up or down, either way, it's moving between 30 and 40, so it's increasing in both directions.
Well, it's okay. So when you say both directions, what do you mean exactly? Do you mean this way?
I mean
and
along
this way?
Along the loop. I guess one of them is down and the other is sort of right.
Oh, okay.
So if you're going along this loop, what's happening, Sam?
As you move away from Q, you're increasing.
Yeah, it's increasing. So what do you think about that, Alex?
Okay.
Do you like that or no? Or
No,
do you believe it?
I understand it, yeah.
Okay, Max, what do you think?
I agree. And I think to further that, I think we could also label I think there's an unlabeled possible maximum between.
Okay, can you point it out? I just made you a presenter, so.
How do I do the arrow thing?
You just go up to the top and there's a little arrow pointer and you just print, yeah.
Oh, right, like there.
Okay, and so that's interesting. And why do you say that? I agree with you, but tell me why.
So I think I agree that on both, on the constraint function, moving away from Q, whichever direction, either up to the right or down, it's going from between F equals 30 and F equals 40. And so I believe that, well, I guess, which point appears to be in there?
Yeah, let's call that point T.
I guess the way I've been considering the graph F is it's almost like, is it it's a plane? Would it be just a flat plane?
It could be. I don't know what it
because
is.
It seems as if it's incrementing in equal increments. So, I mean, that's how I've been sort of thinking about it. And if that's true, I think that the point, what we're going to call T, would be a maximum.
But it's a local maximum, Max, but I know for sure, I know for sure it's a local maximum. How do I know for sure it's a local maximum?
Well, because, on either side, it's going to cross over the line. On the left side, it's going to cross F equals 30 and go down to F equals 20. And on the left, or going up, it's going to go back down to F equals 30 at point T. So,
Coleman, you have a thought or a comment or a question?
Well, I was going to answer your question. There's a point on the constraint where the tangent line is parallel to the lines on the I'm blanking on the name of the graph. On the
constraint or the
this
contour?
type of graph. The contour, the contour lines.
Yeah, and I mean at that point where Max was talking about here, right? As you move along this thing, you're actually going down. So this, I think, is a local maximum.
Yes.
And this is a local minimum. Okay? This is an absolute minimum, and this is an absolute maximum. I think that's cool. How do you like that, Alex? Are you better?
Very much, yes.
And why isn't R anything?
Because if you use this idea both directions, if you go to the left and then it veers to the right, or down to the left and it veers to right, you're going down. And when you're going down, it goes up.
Yeah, and the most easy thing to say is what, Julius?
I was just asking. So our concept of tangent isn't actually doesn't depend on the lines that we see, but more so what we know would be a line.
I can draw any contour right? Because I can pick any number. It's just some constant number of z's. So, okay, cool. I hope you like Lagrange. I think Lagrange multipliers are very interesting. Okay, I'm curious about this. Let's do. Let's actually. Let's see about this. Let's look at this problem. Can you read it for us, Jack?
Sure. The point P is a maximum or minimum of the function f subject to the constraint g of x, y equals x plus y equals c, with x, y are greater than or equal to 0. For the graphs A and B below, does P give a maximum or minimum of f? What is the sign of lambda? If P gives a maximum, where does the minimum of f occur? If P gives a minimum, where does the maximum of f occur?
Now, in all of multivariable calculus, if you see no other thing ever in your life, these equations will come up again for you, these symbols. Like if you take economics in college, you will see these symbols. They're very common ways for economists to deal with functions. They're used in a whole bunch of different ways. So I promise you this is something you will see again in your life. I'm curious. Let's see. Let's start with Jack, can you find, for A, does P give a maximum or a minimum?
P gives a maximum.
For A, which is the one on the left, so which contour are you on? You're at... Okay, and the line is below that line.
No, it's a minimum.
So what do you think? Is it a...
It's neither.
I don't know. Is it? I'm saying it's one of the two.
Oh, it's one of the
It's either a minimum or a maximum, subject to a constraint. Okay?
Oh, so okay.
Okay? So that's just a given.
Oh, when the constraint. Okay.
So what, Eric? What'd you say?
So given the constraint, as in when x plus y equals some constant.
Yeah, some constant.
Okay. So that's those are level curves.
So P is. So what is P? What is it, Eric? Do you think it's a minimum or a maximum?
So I think it's a maximum because inside sort of following along as you follow the curve around, it's decreasing on either side. Right?
Interesting.
F is on. Oh, no, I'm sorry. It's a minimum because. Yeah.
But make up your mind, Eric. Which is it?
Wait. So.
Eric is so changeable.
Yes.
He makes decisions.
Yeah.
I know.
I think it's maximum.
You think it's a maximum?
We never talk about
Charles, what do you think?
You guys said it.
Sorry, in A or in B?
In A.
I think it's a minimum.
Okay, Raheem, what do you think?
I think it's a minimum.
Okay, tell us why.
Well, because on A, if you look at the lines, you have to look at the which way it's increasing or decreasing, and so you can see as it goes to the left, it'll be increasing, and so therefore it's a minimum.
Okay, Charles, why do you think it's a minimum?
When you move along the constraint, kind of the same thing, it goes towards a higher number. It goes from 2 to 3.
Okay, are you convinced now?
Yeah.
So, Eric
I was actually looking at it backwards because the curve. Yeah.
Yeah, it's a little confusing. F1 is to the right. Okay. Hey, Charles, there's another question there. It says, what's a sign of lambda?
The sign of lambda, I think, would be negative.
Why do you think that?
Well, actually, yeah, so it's negative because if you think of, so first you have to think about that gradient. If you kind of rearrange g of x and y into g of x, y, and c, and kind of set it equal to 0, you can see that as c increases, the line kind of expands outwards into the quadrant. And that means that the gradient of the constraint function should be pointing away from the origin.
Do you agree with that, Alex?
I'm not entirely sure.
So the gradient of g, how are the gradient of f and gradient of g related? That's what he's thinking about, I think, right, Charles?
Yeah.
Okay, go for it, Isabel.
Yeah, so the
Isabel?
gradient, the gradient of both needs to, they're parallel. And so I think what Charles was just saying is that for A, like the direction of steepest ascent will be a vector normal to point P, and it's going to be going like to the left because that's the way that f is increasing. So then but here's my question though is lambda doesn't signify direction. Lambda is just like a scalar that you multiply by. So then wouldn't it have to just be positive because the gradient of f is already going to be negative numbers, and then you multiply by lambda? Wouldn't you want the gradient of, or the constraint also to be, oh, never mind, because the gradient, well, I don't know.
If one of the gradients is going
Max?
in one direction.
Go ahead. Go ahead, Charles. What were you saying?
Okay, Charles. So if the gradient of the constraint's kind of pointing that way, and the gradient of the function is going that way, you need a negative number.
Honestly, I'm sort of confused though, because I think of the constraint as like a two-dimensional thing, but it has a gradient that is two-dimensional. So how does...
You can rearrange it into a three-dimensional equation?
Oh no.
If you want to. Wait, Max, what do you have to say?
I was going to say pretty much the same thing. I think the gradient of g is pointing outwards into the first quadrant, and I think whoever said, I think it was Charles, that said in the case of A, I think A and B are actually flipped, but in the case of A, the gradient of f is pointed towards the origin, and so in that case, lambda would be negative, but I think B, lambda would be positive.
Okay, Coleman, what do you think about B? Where is P? Is it a maximum or a minimum?
I think P is at a maximum.
Okay, and why? I agree with you. Tell me why, though.
Because as if you're looking at the higher values of y, as you go from left to right, the function is increasing, and so on the constraint, it's at a maximum.
Mm-hmm. Okay, I agree with you. And then lambda, what do you think about that, Coleman? How would it be positive or negative?
Just going off the last one, I'd assume it would be positive. It would be the opposite.
And why do you say that? I agree, but tell me why.
I mean, I don't know. That was solely based off of the last one being negative.
Well, so I think what Max is saying, or how I would say it, is the gradient of f pointing in the same or the opposite direction as the gradient of g? And so which way is the gradient of f pointing in B? Anybody?
It's
Anyone?
pointing f is pointing to right.
To the right.
Northeast.
Northeast. The gradient of f is pointing northeast. Okay. And where's the gradient of g pointing?
Northeast.
Okay. So they're pointing in the same direction, so the lambda should have the same sign, S-I-G-N, as the two.
My question is, how do you know which direction the gradient is pointing of the constraint?
I don't know. You can tell me that question. Max can tell me, maybe.
Sorry.
No, go ahead.
So I'm maybe doing this wrong, but if g of x equals x plus y, then the gradient would, I think, just be 1, 1. So
Yeah, I mean, I give you what the G is in this question, Isabel.
So, but I mean,
So you
there
actually
is
know what
no
the gradient
visual, No, but there is no visual. You can't be like,
Yeah.
oh, it's rounded, it's convex.
Yeah, I don't think so. I mean, I don't know, maybe, but I don't know immediately of one. Okay, gosh, this is so. I love this. I really do like this. Do we want to try one other problem before we go? Should we try this one? Okay. So here's another one. Shows contours labeled with the values and a constraint. So it says mark the appropriate points at which this happens. So I'm going to give 3 people the ability to be a presenter. And they are Akshay, Alex, and Jack.
Do we do A, B, and C in that order?
So let's try. So pick one. Alex, do you go first? Which one do you want? Mark the appropriate points at which what is that? What does A mean?
The gradient of f equals lambda delta g. Like, what's the constraint? Basically.
So what am I thinking about? So you're going to mark some points on this. So can you do that?
Sure. I will try.
Yeah, thank you. Trying is all I asked for.
Okay. This is very sloppy.
The suspense is killing me. Oh my gosh.
Is it done? Is it there?
I see a yellow thing that's all around the constraint, but I'm not understanding this.
Yeah, neither do I.
Because that is not true.
I'll delete that.
Yeah, that is a falsehood. Logan, can you try?
Sorry.
Are you? What was the task?
To do A.
Yeah, that's actually what I was just wondering. I'm trying to figure out what that means.
Oh, okay. So, can someone help me? Jack, do you want to try?
Isn't that where the gradients are equal, so pointing the same direction, right?
The gradients are equal?
Akshay, help me out.
I mean, different length, but like they're still pointing the same direction.
What has to be true about the contour? Oh my gosh. Okay, Akshay, can you help?
What has to be true about the contour?
What did we decide in the earlier problem about when the contour lines and the constraint and there was something special?
Tangent.
They have to be tangent, right? So that's what I'm actually thinking about. Okay, unfortunately it's 1 o'clock, really unfortunately. Okay, Isabel, tell me what you do. Isabel, quickly, can you tell me what you do to do like A?
Well, to me, there's no tangent point. But if you were assuming that it was at like 9
there so is. You just don't know. I mean, there's one here.
Okay, well, if you're assuming that it's at like 9.5, then
yeah.
Okay, but so then
there's one
let's
here.
say it's at 9.5.
Okay,
then I
but
would
you're
say,
looking for the points where a contour line would be tangent to the contour.
Oh, where it's tangent to
the
some
constraint.
contour?
Yeah.
Oh, and there. And then
Maybe. I mean, it's a little hard to see. Okay, I'll see you all on Thursday. Have a lovely day. Jasper, hope you feel better. You'll be finding like food in the back of your mouth for like months and months and months. He had his wisdom teeth out. Wah, whatever. Okay. See you. Have a good day and stay calm. Bye, everybody.
Stay classy.
Yay!
He can't talk.
Oh, he can't talk.
See you, man. Nice job on the problem.
Bye. How do I disconnect?
The big red button. Or no, it says hang up. It says hang up right there.